For question 13, I clicker for chapter 2, we are given a graph that looks like this. This represents A, this represents B, this represents C, and this represents D. The first question asks, which car is in the reverse direction? Well, neither of these cars are in the reverse direction. So the answer to number 1 is none. Number 2 says, which car is slowing down? Again, neither of these cars are slowing down. However, number 3 asks, which car is speeding up? This is represented by the vector A. This line shows that the acceleration is increasing, so the speed is increasing. Number 4 wants to know which car is not moving, and that is represented by vector B. Number 5 wants to know which car moves in the negative x direction. In the negative x direction. So, if you would guess which one goes in the negative direction, that is D. And finally, a new graph is given similar to the first. Except A is now going down, but B, C, and D remain the same. And it is asking which car is in the reverse direction. The reverse direction would be this vector. Now, question number 7. Draw it out. Now, halfway, we're traveling at 55 kilometers an hour, and the remaining half we are driving at 25 kilometers an hour. On the way back, same thing. We're going back at 55 kilometers an hour, and for half of the way, and the other half we're going 25 kilometers an hour. So they are traveling the same amount of time on both trips. And that is the answer for number 7. Because it provides different answers, and we have to see which one is correct. And the one that is correct is that they're traveling at the same amount of time going in either directions, because the first trip there, half of the way, they're traveling at 55 kilometers, and the second half, they're traveling at 25 kilometers. This doesn't change on the way back, so they would be the same. Number 8 is a little different. It says a third of the way there, they're traveling at 55 kilometers an hour. And the length, by the way, is no longer 100 kilometers. It's 99 kilometers. So a third of the way would be 33 kilometers being traveled at 55 kilometers an hour. And 2/3 of the way, which is 66 kilometers, is being traveled at 25 kilometers an hour. So the total time it would take can be solved by taking 33 kilometers at 55 kilometers an hour plus 66 kilometers at 25 kilometers an hour. And if we solve, we get 3.24 hours for us to travel this distance, for us to travel 99 kilometers. The average velocity, however, is found with a different equation. It would be the distance over time. And our answer would be 30.56 kilometers an hour. Now, to return or to find the time, we would need to use this equation. Knowing that the total distance is 99 kilometers, we'll take t, a third of the time, times 55 plus the 2/3 of the time, which is spent going 25 kilometers an hour. And if you solve for t, you get 2.83 hours. And with this, we can find the average velocity. 99, 2.83 equals 34.98 kilometers an hour. And that is how you solve that question. And question number 9, it says that on dry pavement, braking is 3 times greater than when you would brake on wet pavement. So the answer would be that X. Because on dry pavement, it is 3 times greater, which means that the wet would be 1/3 slower. And you would just represent it like that. For number 10 and 11, I did not understand number 10. I was confused, and number 11 required us to make a question, and I wasn't able to do that because I still was confused. So my apologies.